Hello everybody. Today we are going to talk about how to generate a normal distribution bell curve in Excel. Okay, right here we have the Excel worksheet we will be working on, but before that I want to show you what a bell curve is. Well, this is the normal distribution bell curve. And one of the things that you can see is that throughout the edges of the normal distribution there is very little information, right? And of course the bigger the sample, the more information you get, but the sample or the normal distribution information itself from the data is way smaller on the outer edges. The normal distribution bell curve, what it shows us or it proves to us is that in this part of the bell curve is more than 95 or approximately 95% of all your data is inside here. So most things are going to fall in there. Okay? And we're going to be working on how to create a bell curve like this in Excel. Okay? And one important thing before we do this is that to calculate the normal distribution bell curve, we must have 50 data entries or more. Okay, so we're gonna work on creating that right now. Okay, all right. So let's check it out. First thing that I want to do is I want to insert the data that we will be using. Okay, as you can see here, let me zoom this in a little bit more to 200. Okay, right here in the data information, what I'm going to do is I'm going to put numbers. It could be negative numbers, it could be positive numbers, it could be anything you want really. But in the center, of course, is where we're going to see, depending on the range you get, in the center is where you're going to get, you know, the most of the concentration of your data in the bell curve of the normal distribution. Okay, so right now I'm going to take something. I'm just picking a number pretty much at random. So I'm going to start at 2, for example, and I'm going to increase this. Okay, increase this number by a few decimal points, I guess. So I'm going to add 0.35. Okay, so I'm going to go like this, and I'm going to go to 0.35, and I'm going to go down to 100 pieces of data, just you know, out of basically, so we can, you know, add everything here, and we have more data. The more data you have, it tends to be better. Okay, so now what we're going to do is we're going to calculate the standard deviation increments that we're going to be working with. Okay, so stdev, standard deviation, and the increments. Increments. I apologize for the typo right there. Okay, so we're going to begin with we're going to start with a number that is below 0, and we're going to go all the way up to an affirmative number of 0. Now, to start this, we're going to put the 0 exactly at the center of our data, right? So in this case, we have from 2 all the way to 36.5, but we can always take, you know, one of the cells right here in the middle. So we're going to go to cell 51. It could be 51 or 52, whatever you want. Let's take 50. Let's take 52, just for the calculation. Right here, we're going to put a 0, and then we're going to subtract 1 decimal point. 1/10 of a whole number, so we're going to subtract 0.1. Okay, from here, okay, minus 0.1, and then we're going to take this and we're going to go all the way up. I'm going to paste it right here, so it goes all the way to minus 5. Okay, and down here we're going to add plus 1. Okay, excuse me, plus 0.1. That was a mistake right there. Plus a 0.1. There we go. Okay, and we're going to go all the way down, and we're going to increase it all the way to 0.1. Oh, it's up until 4.9. Let's just add one more, just so we have it all the way up to 5. So we have from minus 5 all the way up to affirmative 5. Okay. Now what we need to calculate next is the mean. Okay. So let's calculate the mean. The mean is basically the average of the data. Okay. So let's calculate the average. The average says here from the data. We select everything, and the average comes out to something like 19.5. That's the average that we have in this whole thing. Now we're going to calculate the overall standard deviation. The overall standard deviation is pretty much calculated based on the standard deviation increments. Okay, so stdev right here. We're simply going to put stdev, and we're going to select all of the data that we have in the increments. Okay, here we go, stdev, like this, and we select all of the data right here. Pretty good. So we hit enter right there, and we're going to have the standard deviation is 2.9300, etc. Okay, now we are going to be able to calculate the normal distribution. Now, the normal distribution is based out of the data information, and it's also going to take into consideration the mean and the standard deviation that we've already calculated. So right here, we're going to put normal distribution, norm dist. There we go. Okay, so for this, we're going to use the formula norm.dist. Okay, the first one, dx, is the data that we're going to take as reference, or the one with which we're going to calculate the normal distribution. So we hit right here, we hit the cell. We don't want the 2, but we want the cell content. Then it tells us the mean. Okay, for the mean, we're going to select this calculation right here. And then standard deviation, we're going to take the overall standard deviation. And then it says cumulative. No, we don't want any cumulative. We're actually going to do independent values. So we click on false. We close the parentheses and we hit enter. And the normal distribution for 2, in this case, considering this mean and this standard deviation, is 2.44 blah, 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 to the minus 9th, which is basically, you know, 9, the period goes, I'm sorry, there's 8 zeros before this amount, and then the 9th value is this 2, if we go down the decimal point. Now, we can just copy this thing and go down, but it's going to be an invalid number because it's now being calculated off of an inexistent value. So in order for that not to happen, we have to fix the values that we don't want to change. In this case, it would be the values for the mean. So we have a better visualization of it. The values of the mean, which is E2, and the values of the standard deviation should not change. So for that, we're going to fix the values with the money sign. Okay, both on the column value, which is the letter, and the row value, which is the number. Okay, so that's not going to change. So now we are able to copy it, and as you can see, it's grabbing the next value in the data, but it's holding on to the same value for the mean and for the standard deviation. Okay, the same thing happens with the rest of the values, as you can see here. So we're going to copy this for all 101 values right there. Okay, very good. So now we have the normal distribution. Now we are actually able to do to create the chart that is going to show us the bell curve. Okay, I'm going to zoom out a little bit so we have a little bit more space to observe the chart right here. So what I'm going to do is I'm going to select everything, and then we're going to modify it so we can see only the information that we want. Now, before I do this, I want to mention that I don't need any information for the standard deviation increments. That's information that I really don't need. I only need the data and the normal distribution. So I select everything, but I'll modify it in a moment. Check this out. I'm going to insert, and you can insert basically, well, you can insert a column, bar chart, or you could even select, a line, a 2D line, etc. But in this case, we're going to use the scatter chart. For this particular case, we can modify it later if we want, but we're going to use this one. All right, so I click on this thing, and it's going to give us this chart right here that is probably not what we want to see. This is very strange. So we're going to modify it so we see exactly what we want. In this case, I'm not interested in the standard deviation, only the normal distribution and the data. So what I'm going to do is I'm going to modify this, and I'm just going to reduce it to the 2 columns that I'm interested in, and that's it. We have the bell curve for the normal distribution. Okay, now an additional thing that I like to do is I also want to prove that, in fact, like we saw in the earlier chart that we were looking at, you could see right here that the values in here inside this bell curve are approximately 95%. So we're going to calculate that, and we're going to see if that is actually true. Okay, so let's check this out. All right, we're going to put ourselves. This is an additional thing that I like to do to prove it to my students. We're going to put right here in the 0, the value of 0 right here. Okay, and we're going to add a bunch of numbers that I consider would be approximately 95%. So I go to the graph here, to the chart, and I look at these values, right? And we can see that these values are incrementing. It's approximately 13.55, and over here is approximately 24.45, as you can see right there in the information. Okay, so I'm going to go from 13.55 to 24.45. Let's hope I remember that. Okay, so we're going to put sum, and then we're going to go up to, and what we have to add is the normal distribution, okay? So 13.55, and then we're going to add it all the way up to 24 or something, right? Can't remember what it was, but it was something like 24.75, I want to say, maybe. But we're still going to get very close to it. So let's hit enter, and it gives us an amount, right? It's 2.71, etc., etc. Okay? So now what we're going to do is we're going to separate all of this into parentheses, like this. We're going to put a division, and we're going to do the sum of everything, of all the numbers in the normal distribution. Okay? So we're going to select now everything. Okay? We select all of them. It's going to be the same column. It's going to get a mistake, but it's okay. It's just going to add a bunch of parentheses. Let's hit enter, and it says 94.9%, which means that it's correct. Okay, and let's put the percentage like this, 94.98%. So it is very close to 95%, which proves that what we're looking at is, in fact, 95% of it. Now so 95% of all the data is actually inside that area. What I'm going to do to show a little bit more of it is I'm going to insert a couple of lines here. Okay, and around here, 13.55, I'm going to write a line here. Okay, I'm going to make it a little bit easier to look at. Okay, so I'm going to put the color in red, and then I'm going to increase the thickness up until 2.14, and I'm going to make it dashed, just so it's a little bit easier to see. Maybe the dashes are probably too big. Let's go to something a little bit smaller, like this. There we go. So, and then I'm going to grab this thing, and I'm going to copy it and paste it, and I'm going to move it over here, which is approximately the same values right here. So everything that is inside these two lines is approximately 95%. As you can see, so we proved with this that the normal distribution bell curve, by making these calculations, it is proving that 95% of the values are in there, and it is proving that the behavior is stable because the numbers are stable. In another topic, we will see in case we don't have that many numbers or we have less than 50. But this is how to create the normal distribution bell curve in Excel. If you have any comments or questions, please drop me a message. Thank you very much.